Welcome back, Linux enthusiasts. This is the 9th episode of our Linux series. If you have missed any of our previous videos, you can check the link above. In this video, we'll be talking about the networking in the Linux. If you are looking to upskill yourself in Linux and get the globally recognized certificate, then I would suggest to check out our DevOps course. The link to the DevOps course is available in the description box. Alright, so let's start the video now. So let's talk about networking in Linux. So if you look at the slides here, you can just check the networking basics. It tells about the TCP. So I'll explain here in a bit what TCP is and what is the networking which is important for Linux. So first of all, we should understand what is an IP address. So there is a common term which basically is used is IP address. Okay. So IP address is currently there are IPv4 and IPv6. So this IPv6 was launched because IPv4 was getting occupied. It was already allotted for the public cloud servers. That's the reason IPv6 launched. And then after that, there were more additions of the IP address were added because there was a limitations which was found, and in some time in the future, the IPv4 will be fully occupied and consumed. So after that, IPv6 will be the common platform where the IP address communication will be happening. So in this we'll be talking about the IPv4. So let's say, for example, a machine has an IP address. So let's say this. So this is an IP address. This is IPv4, and if we talk about IPv6, so this is how something it look like. For example, like this. So IPv4 is always in the 4 octets. Okay. The IP addresses. So see, the thing is, in the world, if we talk about internet, right? So every machine which wants to communicate to any other machine which is available in the internet, it requires an IP address, which means the existence of that machine present in the world. Okay. With that existence, it is able to communicate to other machines over the internet, right? So IP address is a very important term here. So IP address is always in the 4 octets, okay, and there is something called the MAC address. Basically, there is another term. MAC address is basically used for the hardware address. Every hardware machine has this address called MAC address, okay, of their NIC card, which is a network interface card. So that card contains a MAC address, that is by default. Also, we'll be seeing the DNS in the networking. So DNS will be talking in detail that it's a domain name server, which is basically used to resolve the particular domain on an IP address. So and communicate which domain exists where, and that's how it communicates the DNS. And then there are some common terms like default gateways. So basically, default gateway is used to route the traffic when there is a traffic from your local network. Let's say this is a local network, some 10.0.0.0, okay, and there is some other network 192.168.0.1/24. So if you are routing your traffic from the local address to the another network, so in that case, default gateway is the gateway out of which the traffic traverses or goes out of the local machine. And every NIC card, every network interface card has a loopback address, which is default same for everything, called loopback, and that is called localhost address 127.0.0.1. Okay. Now we will be talking about CIDR. So it's very important to know what is CIDR. I'll give an example here. So basically, the CIDR notation is the notation of an IP range. Basically, it is used to represent an IP address along with its network prefix. So for example, if we say 10.1211.55.12/24, so this address represents a CIDR notations. Okay. So if we break down this, we'll get to know that 10.211.55.12. Okay, so this is the actual IP. Okay, this is the actual IP address which represents this specific host on this network, and it has a range, basically the private range available from 10.0.0.0 to 10.255.255.255, which is basically used for the internal networking. So that is the range of this address. Now here /24, what does it mean is that first 24 bits, the first 24 bits are used for the network address, and remaining 8 bits is for the host address. Okay, if we break down this a little further, let's convert the decimal 10. So we are converting this address into binary format to understand this a bit more. So let's convert the first this address, 10. So how do you convert that into the binary? So if you divide 10 by 2, you will get the quotient 5 and remainder 0. Then you will further divide by 2, then you will get the quotient 2, and then you can get it, and then 1, and then after that, if you divide again by 2, you will get it 1 quotient and the remainder 0. Okay, and you again will, if divide this by 2, then you will get 0, and then this is 1. So now the remainders are, if you take it from bottoms, that's how it takes it. It's 1 0 and 1 0. So bottom one should come always on the first preference, and then second one is this, and then third one is this, and then fourth one is this. Okay, that's how it is being considered always. Similarly, if you break the second of it, the 211, if you break the same method what we have done just now for 10, for 211 also, you will get somewhere around 1 1 0 0 1 0 1 1. And similarly for 55 also, you will get 1 1 1 0 1 1 0 0. And for 12 you will get 0 0 1 1 0 0 0 0. So these are the binary addresses that will be coming to represent the decimal. So if you see like this, 10.211.55.12, so you can write it like this: 0 0 0 0 1 0 1 0. This is 1 1 0 1 0 0 1 1 0 0 1 1 0 1 1 1, and then 0 0 0 0 1 1 0 0. Okay, so the subnet mask, what is the subnet mask here is /24. That means the /24 represents 255. So the first 24 bits, the 3 octets, basically are the network portion. So 255.255.255.0. And if we calculate this in the binary, it will come somewhere around 1111 1111, same 0 0 0 0 0 0 0. Okay, 8 times octet. So that is how it will break down: 255 255 255 and 250 and 0. So that's if we try to calculate the network address, so network address will be calculated as a portion of initial 8 bits. So that's how you can do it: 10.211.55.0. So this address will be the network address of this range. All right, so we see this, that 10.211.55.0, this is the network address. And if we calculate the usable host, so how we can do this is since this address is already being associated for and assigned as a network address, and the last address of this would be 55.255. This will be reserved for the broadcast address, and this is network address. So the usable range, if you calculate, it will come somewhere around 10.211.55.12, 10.211.55.254. So till this range, from this to this, these are the IPs which will be usable and can be associated to the machines. And if we talk about the broadcast address, so broadcast address would be for this network range is 10.211.55.255. So this is the broadcast address. Okay. So if you look at the summary for this range, 10.211.55.254, 55.12/24, the network address is 10.211.55.0/24. Okay. The broadcast address is 10.211.55.255, and usable hosts are from here to here. Okay. So that is the kind of overview about how do you break down a particular IP range and how do you calculate the number of usable IP addresses in that range. So this is very important in order to understand the networking basics. So that's why I'm explaining this here. And there are some private range IP addresses which are available for the machines which are not publicly hosted. A private range, any cloud, locally cloud, if you are building up, or any enterprise cloud you are building a private network, so you can have a private range. So private range is basically predefined from 10.0.0.0 to 10.255.255.255. Okay. So if you see the address for this would be /8. There is one more, 172.16.0.0 to 172.31.255.255, and this is 172.16.0.0/12. So if you calculate the 12 here, so you will get to know that okay, initial 12 bits will be for the network and the remaining will be for the IP addresses assignment. So then similarly there is one more range, 192.168.0.0 to 192.168.255.255, and that is 192.168.0.0/16. Here the 2 octets will be assigned as a network address. So that is private network addresses range that we have. Now there is one more thing called NAT. Basically NAT is nothing but networking translation, address translation. It's basically used to communicate the internet, and which is very important because when a router changes the private IP to public IP for outbound traffic, so from the router, if there is any outbound traffic which is going from the private network to the public network, it requires NAT from where it is going to translate that IP address. So in order to translate it, it's using NAT, which is very important to know. All right. The public, the remaining ranges, whatever is there, those are for the public ranges apart from these 3 ranges. And if we talk about the Google's IP address, DNS server's IP address, 8.8.8.8. So these are the things you should know by heart, that because you will see this many times in the configuration files of the DNS. So this is a Google DNS server IP address. Okay. Now we will talk about the clouds, that various clouds which are using. So why did I spoke about this is because for AWS has various machines AWS machines, EC2 machines, which has the IP address associated to it. So we should be aware about the public and private IP addresses. Without that, it is going to be tough to understand what is an IP address and how to assign and stuff, right? So that's why it is very important to know the IP addresses. So now we'll take a look at the DNS as well together here. So let's just see. Here we are talking about DHCP and DNS servers. So in DNS and DHCP we will be talking about like this. So let's say DNS, what DNS does is, DNS is basically used for domain name resolutions. So what is a domain name, right? So in order to communicate to any entity which is existing in the world has a name associated to it. It's called domain name, right? For example, you must have seen google.com or facebook.com or instagram.com. So these are nothing but the domains that people purchase it, and to purchase it they have to pay something to the vendors who are selling it up. For example, GoDaddy, they sell the domains. You can purchase the domain from there, and they can host the website also if you would want to. There are few other vendors available in the market. You can just go with this. This is an example. But how does a DNS work? So let's say there is a client machine. It has some IP address 10.0.0.27, okay, and this machine wants to communicate to the cloud, okay, let's say Google. So there are a lot of things which comes into picture. There are in terms of networking, if we talk about from the layer wise TCP IP layer, and then there are a lot of things, but we are currently discussing about the domain, how does a DNS work. So DNS basically, when you are typing in your browser tab www.google.com, so you are asking that give me the IP address of the Google, because see, every machine, this is nothing but a host address, okay. Every machine has an IP address. So let's say Google IP address is example 8.8.4.4, okay, that's called IP address. Now you are asking that give me this IP address, okay. So now you are asking to which DNS? To your local DNS. So first of all, for any client machine, the local DNS entry in the Linux machine is present under etc hosts, okay. After that, it will check the result.conf, okay. These two, if in the etc host file, if it has the entry for google.com, okay, or usually it has the entry for name servers, that which DNS you have to go to, okay. And similarly, this also has the entries for the name servers, that which server you have to go for the resolution. So let's say, for example, it has the entry for google.com that the IP address of Google is 8.8.4.4, okay. So now how does it happen is, it just directly goes to the Google from the cache itself and then loads it up. But what if we don't find the Google's IP address, So what it will do is, it will, let's say you're connecting to the internet Wi-Fi, okay. So the first request which goes from your machine, it goes to the DNS server of your Wi-Fi vendor. Let's say you're using Tata or Jio internet or whatever. So let's say Jio if you are using, so it goes to the DNS server of that internet provider, okay. Now that internet provider has the root table, the DNS table of all the various public cloud domains. Why does it have is because that's how the DNS system works in the public internet, where it spreads out the information whenever there is any new changes happen in the configuration file. So I'll talk about the hierarchy of a domain. How does it look like? So it starts from the dot. We call it a top level domain, okay. So the short term is TLD, top level domain. The dot has lot of branches, okay. For example, com, org, in, edu, or let's say gov. Okay, there are a lot of branches of dot. So under, let's say, com, it has Google. In com it has Facebook. Okay, similarly for org, let's say it has some organization, let's say Bharat Petroleum. Okay, so these companies have registered or purchased their domain from particular vendors. So let's say google.com, right? So google.com has many other branches. Google has many other branches. One is let's say mail.google.com. Okay, that is a mail Gmail service. You have a docs.google.com, that is a document service of the Google. You have drive.google.com. Okay, you have www.google.com. So this www.google.com is where we would want to reach. That's where the search page opens. If you open drive.google.com, the search page would not open. If you open docs.google.com, then search page won't open. So what does it explain? It explains that all four hostings are different. All four hostings in the public internet is hosted on different IP addresses on different machines. Okay, so www, let's say for example, hosted on 8.8.4.2, drive.google.com is hosted on 4.4.2.1, something like that, So now what happens is your internet provider DNS has connected to the DNS from where it is getting that entry. Now what it does is it goes to the top level domain. If it has not found the entry from top level domain, it goes try to find .com. Okay, it is able to find that. After .com, it goes to Google. Okay, google.com. After that, www.google.com. So once it gets the IP address, it returns back into the Google, and then from Google to com, and then TLD, and then after that it stores that IP address information in the DNS table. Why does it store? So that next time you should not take so much of time. So if you remember, or if you have seen in your life, for example, you have purchased a new system, new laptop, and you have a new internet connection, and when you search google.com, it takes a seconds of time sometimes to load initially. Why? Because at that time your local DNS cache and the cache of your internet provider is fresh. There is no google.com entry present. In that case, it has to go through all this path and then gets the IP address. Once it gets the IP address, it stores in the cache, so that next time whenever you search google.com, it will, within fraction of milliseconds, it will load the page for you, unless that website is down. Okay, so that is the advantage of using DNS. And everywhere in this public cloud internet, whatever you are accessing, whatever the applications you are using, it has to require DNS services. Without DNS services, you will not be able to resolve the IP address of a particular domain and won't be able to access that domain respectively. So that is the advantage of using DNS servers actually. We'll talk a little bit about TCP as well, because TCP is a very important transmission control protocol. What it does is it makes sure that a client which wants to communicate to the server, okay, it creates a legitimate connections which make sure that, okay, client is connecting to the right authority or not, right? How does it do? So TCP works in three-way handshake. Okay, three-way handshake means there are three ways. One way is you are sending a signal, SYN packet. After that, server sends the response back with a packet called SYN and acknowledgement of the previous SYN what you have sent it. Now again, client sends, okay, it acknowledged your SYN which server has sent. So basically it is like handshake. What is handshake? When you go to meet somebody, you handshake, right? Which means you are agreeing to the both parties. Okay, we are meeting, we are doing handshake, which means that we are knowing each other. That's how in the real world also, TCP connection does a handshake between two parties. Let's say client and a server. It does the handshake, but it has a process to do this. For example, it do a three-way handshake where it's a packet-wise, SYN, SYNAC and ACK. That's how it does the handshakes. Similarly, whenever you open any secure website, HTTPS, all the websites, if you have seen, it starts with HTTPS. HTTP means a website which is not secure. Okay, this S makes the website secure, which means it is running on a secure server. It's running on a secure way. How does it make sure that it is running on a secure? Because that's where the client and the server, they both agree on their own conditions, where a client says, I am using Firefox, for example, version 2.24. Server says I am using Firefox, I'm supporting that version of Firefox till 2.25. Okay, I'll support yours as well. Then it says I am using TLS version this 1.2. It says no, I am supporting only 1.3. I will not support 1.2. In that case, connection may not happen. So sometimes server will fall back, but sometimes server accepts the connection. So that's how both parties, and then there is a certificate also gets involved. So certificate is what we see when we click on that lock icon in your browser tab, right? When you click on that, there is a lock. When you click on that lock icon, you get a certificate, or certificate is still valid. That's why it's a legitimate website, in order to make sure that. So yeah, so that's about the theory of what DNS is and IP addresses. Then DHCP server is another server which is basically being used in the various systems where you have to dynamically assign the IP address to the machines where you don't want it to be manually assigned, right? That's the case where you use DHCP servers. Now we will go to the hands-on of all this what we have discussed here. So let's proceed to the hands-on. Yep. So we will be talking about that IP addresses. How do you see the IP addresses, and how do you find that information? So there is a command called IPA. So this command tells you what is the IP address that is basically assigned. So if you look at here, there are two types of NIC available. When I say what is this is interface. As we have already talked, that interface is something it's a physical network interface card. If you don't have that network interface card in your laptop, you will not be able to assign any of the IP addresses, any physical IP addresses, because it requires a physical network interface card in your system, and every laptop and every machine has a network interface card installed, okay, if it wants to communicate to some other machine. So otherwise you can have a option to choose the virtual IP addressing and stuff. We will talk about that as well, the virtual IP addressing, but it has to have the physical NIC card. Without that, IP addresses won't be assigning, and then won't be usable for the system to communicate into the world. So this has IP address, as we have discussed. This is nothing but a CIDR format of IP address. The 24, which means the 3 octets are being used in the network address, and then remaining one for the host address and stuff. So that we have already discussed. Here you see the broadcast address, what we calculated earlier and seen it. It's 10.211.55.255. Okay, and then this is the loopback address. Every local machine has a loopback address assigned, and it's the same, 127.0.0.1. That is same for every laptop in this world, every machine in this world. Loopback address, every machine has it. That's the same. Now, how do you check the network interfaces of their IP addresses configuration? So there is a command called nmcli device status. So it says, okay, currently there are 2 devices. This is okay. Loopback, you can ignore loopback because loopback will anyways be there. But let's focus on this Ethernet device. So this is an Ethernet card that is plugged into my laptop, and that's how I'm able to see, oh, it's naming as ENP0S5. This is the device name, and it is corrected. Okay, and the connection plan, it is saying net plan. Net plan is nothing but a service in Ubuntu which basically configures that networking configurations available for the machine. Okay, now let's try to test the connectivity. How do you test the connectivity to Google? For example, how do you usually do that? You open a browser, go to the tab and say www.google.com. But what if you don't have a browser? Then how will you do that? So for that case, you can use various CLI tools to identify if you are able to reach to the Google, or if the Google page is loading for you or not. So one of the command is ping command. Let's say ping google.com. Okay. If you are getting the response back, since we are getting the response, I'm connecting to the internet, and I'm getting the response back from the Google IP address, which is this one. And this is so ping is a command which basically works on ICMP, packet transfers. So here we are getting that, okay, you are getting the response back, the ICMP packets, whatever you are sending, you are getting the response back for the request that you have sent to the Google, which means you are able to make a connection to google.com. Okay. And let's say if you want to send ICMP echo request to check connectivity, you can do this, let's say for example, just 4 times I would want. So it will just run for 4 times and it will break. So what this command does is, so this command will keep on running all the time until you interrupt it. But you don't want it to run for infinite time. You just want to send the ping request for limited time, let's say 4 requests, and then close the connection. So this command is helpful just to say 4 time request sends to this IP address 8.8.8.8, and if you are getting the response back, which means we are good to get the connection. We are good to proceed with our connection and can do further whatever we would want to do it. Okay. To check the DNS, there is a command. There are three, 4 commands to check it. One of the command is dig command, which will show the detailed information about your domain name services. So let's say we try to check the dig for ubuntu.com. So here you can see there are a lot of response we got here. The important things to look at it, that ubuntu.com answer, so you're seeing small a, capital A here. So this capital A single shows the IPv4. If there are 4 A's, which means it's IPv6. So that's how it explains. Single A we are seeing here, there are 3 IP addresses assigned to ubuntu.com. You must be thinking why there are 3 IP addresses assigned. Because see, any services, any server which is running in this world should not have just a single machine. What if that machine goes down, right? So it should have a backup always. We call primary and secondary. So for example, I would say if it has only one IP address, what happens if that IP address goes down? Then you will not be able to further communicate to this. That is the reason it always have multiple IP addresses in the load balancing format, and in order to communicate different machines present, maybe sometimes it presents those machines in the different geographical locations, so that it's easy and less time consuming for the people who are accessing from their region. For example, from Mumbai, if I'm accessing google.com, what do you think? The Google request, the google.com request, does it really goes to the Google United States? Not really. Why? Because Google has their data centers in India as well. So my request reaches to the nearest point, and from there, if I have that pages and whatever I'm requesting, if I get that, that's it. So those servers which are lined up in the geographical locations always have sync between each others. So it's always easy for the people who would want to access it from a respective regions. So that's why it's always, it's always like this, that from wherever location you are trying to get the response back from any servers, or you're trying to connect, you always try to connect that to the nearest one. If in case that nearest one server hosted does not have the relevant data information what you are looking for, in that case your request will be forwarded to the main server, and then it might take some time. So sometimes you see there is a website which only is hosted, let's say in Canada, and you are accessing it from the India. So from India to Canada, whatever the time it takes via internet, that time you will see the latency over there. Okay, website is not loading, or it is not loading properly, some contents are showing up or not. So those blockages could be because of internet, or could be because of the distance travel, whatever it does. So it's always preferable to have multiple servers hosted across various geographical locations, so that you can easily connect and with the less time consumptions. So that is advantage of having DNS hosted on the various geographical locations. So now there is one more command for check the DNS entry, that is NSLOOKUP. It is not as detailed about server and query time and stuff as what dig says, but yes, it can tell you the IP addresses of Ubuntu machines. So these are the 3 IPv4 what Ubuntu machines are currently running on, and these are the 3 IPv6 where the Ubuntu machines are currently running on. So which means ubuntu.com website is currently running on 6 different locations. 6 different servers are running the same website. If any of the server has a high load, or a lot of users have connected to a server, then the request will be automatically internally forwarded to another server, in order to make sure that consumer, the users who is trying to access, should not face any downtime. So for example, you also must have seen the real-time scenarios when Flipkart does a big billion day sale, or Amazon do a big billion sale, their website does not go down usually. Why? Because There are a lot of latency people created because of the lot of traffic coming to the same website at the same time. Oh, there is a sale going on, everybody wants to buy stuff. But what if they only have a single server and it has a capacity to handle, let's say, 1 lakh user? What if more than 1 lakh comes in within seconds? Then how will server be able to handle such requests? So in that case, it's always preferable to have multiple servers located, as well as has the replica of all the same things, databases, so that if one server goes down or if the one server goes out of limit, your request will automatically being forwarded to the another server. But user will not get to know that, okay, you were trying to connect to India server, but unfortunately India server was already occupied, so your request has sent to the Canada server or some other server. It happens within fraction of seconds, so user does not really get to know there is a slowness or a latency problem. But that is how it is working, and that's how it is surviving also. So it's always preferable to have multiple servers located into various locations, and that's how we call it, hosting, on-demand hosting and dedicated things. So that's how the real world works in this case. So we can learn and see things like this. Now if we look at IP route command, so IP route command is basically trying to tell me that via this IP address, whatever the traffic you're trying to send to the internet will be going up. So this is that interface route it will follow in order to make any connections outside. So that is what the IP route command basically tells. Now let's managing some networking interfaces. Let's try to set it up if we are able to do this. So we will use ifconfig command. There are multiple other files and commands present which can also do the same stuff. We will see that as well. So first I am using ifconfig command. So let's say enp0 5s :1, and I'm assigning an IP 10.0.0.50 and net mask 255.0.0.0 and up. Okay, it will ask my password, and now let's see this, what change you find. So as soon as we try to add another interface, so this is nothing but a virtual interface we are assigning here. So the virtual interface, so currently we have one single interface enp0s5, but with the help of this command, we have temporarily created one more virtual interface which has the IP address 10.0.0.50. This is that network address range, and this is the broadcast address. So you have virtually assigned one more IP address to this interface. So that's how you can do this. After that, if you would want to shut down, let's say you can link, let's say enp0s05s 5 down. Okay, what happens after that? Okay, so now all these things will be going down, and then it has just that IP addresses. So this is basically to set any interface down, and you can just set it up as well. Okay, to bring it up actually. Earlier we saw this is current. This was showing the state as a down, but now it shows the state as a up. So that is a difference. In order to see that state, how do you change is how do you make your network card to be a down state, but usually you want it to be running, so that's why it's always to keep it up. Yeah. After that, let's assign an IP address that we have already did, but let's use some other command. There is a command called ipaddr add 192.168.1.50/24, then dev enp0s5. Okay, let's see what happens now. Okay, one more thing is, if you run command ifconfig does not show you the secondary IP addresses. It always shows the primary IP addresses, whatever has assigned to this machine. But if you want to see all the IP addresses, then you can run command ipa. So now you see we have this IP address assigned 192.168.1.50. That is what we have given here. So that is how you can assign an IP address. Okay. Now we have checked the interfaces using ifconfig command. That's fine. Now let's see, sometimes if you are not able to use if config command, then you need a software in order to use it. So the software name is net tools basically. You have to do apt install net tools. Okay, so since it is already installed on my machine, that's why we are able to execute the ifconfig and necessary commands to validate the networking part. Okay, now let's check the open connections in the Linux systems. So currently it is connecting to this local port. This is a local port, and this is the HTTPS address. Okay, this might be some public IP address I might have been connected in Firefox. So if let's say you can reverse lookup as well to try to check if you are able to, yeah, you are able to find that IP address belongs to some user Google user contents. So let's display the listening TCP ports. So you can do that by using, so these are the TCP ports which are currently in the listening mode. So you can see like this. If you want to monitor the TCP traffic, so you can use TCP dump, then -i, then P0S5 and TCP. Okay, so it is listening currently. As soon as you initiate any TCP connection, it will start capturing. See, as soon as I hit it, so it is capturing all the packets which are, so this Wireshark is a tool which is basically used to capture the traffic. Similarly, TCP dump is nothing but a Linux utility. But once you dump that output into ICAP file, you have to read it via Wireshark only. If you're reading it in the GUI, the good format in Windows, you can read it like this. In Windows, you can still, sorry, in Linux, you can still read it via TCP dump command. That is fine. But TCP dump is the same utility is what Wireshark does, but that is a UI based tool, and this is a CLI based tool. So it tells about the connections and whatever ports are being used and IP addresses are being used. So I'll just cut the connection. So far it has captured this much traffic and received it. Okay, now let's test the TCP connection port connectivity. So you can use command netcat and see, and then 192.168.101.80. There is no connectivity at this moment. If there is any connectivity, let's say, let me check the IP addresses. Let me try this one. Okay. Okay, it says succeeded. Why is it? Because this is my local IP address of this machine, and on this machine I have some websites hosted that will be talking about once we will be hosting the website, right? So this is hosting on the local host. Okay, so these are my local website which are currently hosting. That's the reason it is saying that it is able to connect. Similarly, if I try T8, it will connect to the local. Let's try local loopback as well. It will connect to the loopback address as well. There is one more command, telnet command. The telnet command basically .50. Okay, so telnet command also tells us about how do you are you able to connect to a remote server or not. So if you get this connected to this, which means you are able to connect, which is my nothing but a local machine on port 80. You remember when we were talking about the Linux file types, so we discussed about that socket type files, right? So in this case also there is a socket type files which might have been created for this socket communication. So currently, since it is a local thing, right? So in the local system, the socket connection is established to itself, and then on port 80 it's able to listen and then respond to the user. Yeah, okay. Now let's talk about if you don't have a browser, then how will you read and try to find the page, So you can use this command curl v and then say local 8080. Okay, so see, whatever I was getting here, localhost welcome to 𝐘𝐨𝐬 web server. The same thing, I'm getting the response back. So I'll explain what is this actually doing. On the localhost resolved, IP address is this, connected. Basically this is nothing but a HTTP header. So there are a lot of headers. HTTP is basically trying to connect. Let's say get is there, then post is there, put is there. There are a lot of headers. So this is using get header in order to fetch the data. Okay, from where? Localhost. And what is a user agent means? The application it is using. If you are using Firefox, then you would have get Firefox. But since we are using a curl utility, so with use curl, you can just see the user agent is curl defined, and this is the version of curl that you are using. Now this is the request that you have sent, which is called HTTP request, and this is called HTTP response. Okay, so the response that you got from the server says okay, 200 okay means okay, you got the response from the server back. And what is the response content? It says welcome to 𝐘𝐨𝐬 server. This is as same as what we were getting by the browsers. Okay, so and content type was in text HTML. It's a plain HTML, nothing fancy. So that's how you can check. And if you are checking the TCP statistics and socket statistics, so you can run command netstat and st. So this will tell you all the stats of your TCP, how many connections active are there, how many passive are there, failed connections, and so stuff for UDP Lite, and so like that you will get all these information about your TCP stats. And socket stats you can get it SS-S. So all these total sockets, TCP connection which is currently active on the socket is 10, established is 1, time wait is 2. So something like that. You get all the information about your socket stats as well. So basically, so this command is just to give you a quick overview of active connections, network connections. It's helpful actually to check the overall network states, and it identifies, if in case you want to identify the issues in terms of connections, so you can do that and troubleshoot it as well. And so common TCP port that you should remember, 22 is being used for SSH service. Okay, 80 is for HTTP, 443 is for HTTPS. Okay, after that 3306 is for MySQL. Okay, 53 is for DNS. So then 21, 22 is for FTP servers. So they are like that. You have to remember this, because that's very important. So common ports, what are the common ports for a respective web services or some other services which are there in the market. Yeah. So that's the conclusion about the TCP. How does the TCP is being initiating a connections, and how do we troubleshoot, and how do we see with the help of Linux commands. And then if we talk about DNS, that we have discussed about dig command, NSLOOKUP command, and there is one more command called host command that can also give you, but very shorter than NSLOOKUP. So host and then NSLOOKUP and then dig. So these are the three level of information that you could gather for the DNS host servers. If you want to configure so this is the file I was talking about earlier, etc host file, which has the entry for my websites also and localhost, and there is a file called resolve.conf which has currently it's not present. So let's see if it is present. Okay, it's not there, that's fine. So usually resolve.conf has an entry if in case you want to communicate to the name server information. So maybe I might be using some other name servers, that's why resolve.conf does not legitimate here. If in case you want to set up a custom DNS, so you can do this by using command netplan and whatever the YAML file you have. So this is the example of netplan file. This is my IP address, and this IP address I chose it for the secondary, but currently it's commented, so it will not be eligible. This is the default route which it should go traverse to, and these are the name servers. I have given the entries of name servers itself in my netplan itself, so there is no need for the resolve.conf anymore. Now you can just get the reference from here itself. Okay, if you would want to apply changes to the netplan, you can do this, sudo netplan apply. So it will apply the changes if in case you are making any changes in this configuration file. This configuration file can vary based on whatever the system you are using of Ubuntu. Sometimes it's 01 cloud, net CFG YAML, sometimes 01 init cloud YAML. So it could be anything ending with the .yaml as in its suffix. Now there are few files we'll be talking about in DHCP. So DHCP servers are basically is used to automatically assign the IP addresses for the machines which are needed in the network itself. So it does the discovery of the client IP addresses. After that, it offers the IP addresses actually to the client, and then client sends the request of the offered IP addresses, and that's how it acknowledges the client request and then gets the response back to the client. So there is one more but it requires a package to be downloaded first, and then only you can communicate to DHCP. So this is the file DHCP .lease file. That is a file which contains the entry about the DHCP things. So this is the package which is required for the DHCP, very important. So if in case you want to set up a DHCP server, you need to download this ISC DHCP package via apt install that we have already discussed in the package manager episodes. Okay. And then the documentation, if you want to check the documentation, you can just go to the release file manual page, which is on the Google SL. Also, you will find it up. And then let's say you want to, DHCP. These are some commands I'm telling DH client command -r to lease, renew the lease. So that's how you can renew it, -r. If you want to really renew the lease, if in case you are, the entries that you are adding up into the lease for the files. So that is all related to the configuration that we are not doing here. We are just seeing how to, basically understands what are the files which are really common for the DHCP servers, Let's talk about some, static IP addresses. How do you set it up? So, for example, one way is we already saw here, net plan commands. In the net plan configuration, you see the IP addresses which are there. So, you can set up this IP address. Let's say if I do this, okay, and let's say net plan apply. Okay, now let's see. So you see this IP address is also associated. Plan, whatever it is. Okay. See, this is the same IP address, we uncommented it, and that's how it got allotted by default. So that's another way of doing it permanently using netplan. But if you want it to be set up for temporary, you can use ifconfig command or IP address command that we have already checked out here. Then there are some common tools which you can use for DNS. DNS mask is one of it. Then bind9 is another one you can use. And for DHCP, you can use DHCP clients to manage the client lease and all. Now let's talk about basic networking commands. For example, ifconfig, there is one more command I would want to show, resolve CTL and status. Okay. Okay, currently it's not running because it requires system resolve to run, because I am using DNS masks. So if I want to run this command, I need to switch this on. We will see how to use systemctl when we are going to use this command, but I'll just show it here. You have to start the service call systemd and then resolved. Okay. So now you will see the status. So these are the global DNS server, okay, whatever is assigned 10.11, and these are the DNS entries that is being coming up from the netplan configuration file for this ENP0S5 Ethernet. Okay, so now I will disable this for now. Disable will stop it and then disable it, which means whenever the system will reboot, it will not automatically enable. That's what disable means here. Okay. If you want to see the full traffic that on a particular interface, so you can do TCP dump -i enp 0s5 -n. So this is how you can basically see the full traffic, including the local interface IP. Or there are some other ways as well. Let's say if you want to see on this host google.com, only the google.com thing. So let's say if I go here and say google.com, so you should supposed to see google.com thing, TCP dump -i, say host google.com. Or let's say there is one more command called mtr that also shows the google.com. So this is very helpful in order to troubleshoot where you want to see the packet loss, how many packet loss is there, and you can just check what are the pings based on this ICMP only. It is trying to find out the losses which is happening in the system whenever it is trying to reach to the Google and get. So it's like a live response back from the Google itself where we are trying to troubleshoot the. So it's kind of a trace route, back trace route actually. So there is one command called trace route command, which is very helpful just to see how the traffic is being flowing to google.com. So maximum it takes 30 hops. Hops means router by router, the machines which are coming in between the client and server, those are called hops. So these star means either it did not receive the IP address or there might be a firewall which is engaging in between. So trace route basically is a good command just to get the response. So not Google, then let's check for ubuntu.com. Okay, if we are getting any response back. Yeah, here also we are seeing some sort of firewalls which are being involved here, and we can just validate this further. So if we try to see any of the trace route things, right, so usually we are getting star. There could be possibility that it is having a firewall or due to which we are unable to fetch the real IP address. So we can do something like local hosted website, so which I have done here. Let's say mywebsite.com, and if we try to find the trace route for this mywebsite.com, so I'm getting the single response back saying that this website is hosted on this IP address and this much total time is what we got in order to reach this website. So that's how you can actually locate and try to fetch the route, how hop by hop the ping is there, and then how are you getting the response back, from which IP, the target IP you got the response back. Since this website was located locally on my machine, that's why we were able to get the response quickly from the local host. So this IP address is nothing but of the local host IP address, and that's where the website is currently running in the Apache 2 format. So these are the general commands that we would want to discuss in terms of troubleshooting the networking scenarios, or in order to see how to check the DNS configurations and stuff. So let's recap this quickly. So we just discussed about the IP addresses. What does an IP address look like? IPv4 and IPv6. Then there are private cloud and public IP addresses. There are 3 specific ranges which are being allotted for the private ranges, and then remaining of the ranges are associated with the public cloud ranges. Now if we talk about IPv6, the requirement for IPv6 created because of shortage of IPv4. In some time in the future, IPv4 will be fully occupied and used. That's the reason now companies and the people who are running their websites on the internet, they are going with the IPv6. So after that, we saw how does the DNS work, what are the DNS configurations files, and how does the DHCP work, and it tries to associate the IP addresses. Then we checked few commands to see the socket connections and the TCP connection, and telnet command, netstat command, and netcat commands just to analyze the socket connections open and listening TCP connections. Then we try to see how to trace route and backtrace for any host address to identify the location of it. how to check that using traceroute command. Then mtr command is additional tool you can perform where you can check the packet loss which has happened for in order to communicate to the server. After that, we also see the tcp-dump command, which is nothing but you can say the alternative of Wireshark. And similarly, you can trace the packets whatever is going on your network interface outside of your laptop machine, and then you can check that as well and try to identify the problems if there is anything has been detected. So that's all about in the networking, basic networking of and the basic commands which are needed for the Linux systems.
If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.